All right, so let's check out this vector decomposition problem. It's a little bit different than some of the others we've seen because the vector f that we're trying to decompose is at some orientation or some angle theta. And then the basis vectors we're trying to put this into are also at some other angle I'm calling phi that describes its orientation. So there's going to be a little bit more work on this one, but the principles are the same. That is, we're going to take this and we're going to draw one of these forced triangles. So the vector f here is on the hypotenuse, and the other two sides coincide or are aligned with the e hat 1 and the e hat 2 directions, like so. So in particular, if I want to do this thing, I'll start off at the base of f and I'll start moving along in the e hat 1 direction this much, and then I go in the e hat 2 direction this much, and connecting these two vectors tail tip to tail, tail to tip, I get that this vector plus the vector in the e hat 2 direction add up to the f. Now all we have to do, or at least the next step, is to identify an angle, an interior angle in this forced triangle. And the one that I'm kind of interested in, I already have it marked down here, is this angle right here. It's the angle between the vector f and what is the e hat 1 direction. So it's this angle, right there, that I'm interested in. Right now, if I extend this f vector out, you'll notice that the f vector made an angle theta relative to the horizontal. So this theta relative to the horizontal is exactly this theta relative to the horizontal. So this vector I'm interested in is going to be theta minus phi, right? That's how I get that little difference vector right there. So again, this angle over here that I'm interested in is going to be theta minus phi. And once that's identified, it's pretty much a normal sort of vector decomposition problem. So I notice that the e hat 1 component, that's this side right here. That's the side that's adjacent to my angle of interest. So I have a cosine of the angle in there. And the e hat 2 component, that's the opposite side. It's the side opposite of the angle, so that's why I have a sine there. And notice that, let's just get the signs right. So this e hat 1 component is in the direction of the positive e hat 1 basis vector. And similarly, this e hat 2 component is in the direction positive to e hat 2 basis vectors. So both of these terms have are positive. I'll say it that way. And well, I guess that's it really. That's my answer right there, fully justified.